In this video, you are going to learn about molecular and ionic compounds. Let's review the periodic table. Over here, the periodic table, you can see different colors. For example, you can see blue color over here. That's the Br, bromine. And you can see the blue color over here. That is Hg, that is mercury. Okay, the red color elements on the periodic table, and those are gases. They are in the gas state at 1 atmosphere and at room temperature. Okay, you can see different colors. For example, there's a staircase line over here that is purple color. On the left side of this staircase, it is called metal. And on the right side of this staircase is called non-metal. So this side will be metal, and this side will be non-metal. When we say metal, we exclude this part. Hydrogen is considered as a non-metal. Okay, so what is the most metallic material? That will be lower in the periodic table and on the left side. So it will be somewhere in this corner over here. It will be very metallic. On the other hand, which elements will be very non-metallic? Over here, it should be on this side of this corner of the periodic table. What do we call the elements on the staircase over here? It is called metalloid, or someone can call it semiconductor. Okay, what are the other properties? Each of this column, group number 1, group number 2, group 17 and group 16, group 18, they all have their names. And you have seen that before. Group number 18 is called noble gas. Number 17 is called halogen. Number 16 is called chalcogen. The first group is alkali. Second group is alkaline on earth. Alkaline earth. Okay. Now, let's see what is considered as an ionic compound. Okay. An ionic compound, especially a binary ionic compound, it is when a metal and a non-metal react, it will form an ionic compound. Let's look at it over here. Which other metals? Well, anything on the left side of this purple staircase, everything with the beige color, these are metals. So when a metal react with a non-metal, which is on the right side of the staircase over here, it will form an ionic compound. Let's look at examples. For example, Na, that is sodium, Cl, that is chlorine. When Na, sodium, mixed with chlorine, it forms sodium chloride. There is a special way of naming these binary ionic compounds. The first one we just have to name the element. In this case, it is sodium. The second element, it is chlorine. We have to change it and it will become chloride. It must be ended with IDE. Whenever you see a binary formula that ends with IDE, that means it is an ionic compound. Let me repeat that again. The way that we name it, it is by first writing down the metal, and secondly write down the non-metal and change the non-metal to end with IDE. Okay, can we get another example? Yes, let's see. We have calcium over here and we have chlorine. So that will be CaCl2. It is calcium chloride. Pay attention here. There is no indication of the 2 over here. It is just calcium, and then we say chloride, sodium, chloride. But how can one differentiate whether it is NaCl2 or NaCl? Or can we just say CaCl instead of CaCl2? The answer is no. There's only one formula for it. That's the property of ionic compound. For ionic compound, we can actually write down the formula without listening to the names, without hearing the number over here. So how do we predict the charge of the metal or of the non-metal? From here, a few groups that we can predict the charge. For example, group number 1, it always try to form a 1 positive charge. Group number 2 always try to form a 2 positive charge. Group 17, that is the halogen, it prefer to form 1 negative charge. And the chalcogen, group number 16, it try to form 2 negative charge. So how do we predict the formula? The net charge should be add up to be 0. For example, in this case, calcium is from the alkaline earth, and therefore it prefer to have a 2 positive charge. Chlorine is over here. It prefer to have a 1 negative charge. That's why we need 2 of them over here. To sum up, we have a 2 negative charge in order to cancel out the 2 positive charge here. Likewise, sodium is from the first group, is from the alkali. It prefer to have a positive charge. And chlorine from the halogen group, it prefers to have a negative charge. And therefore, 1-to-1 ratio, we can end up with a 0 charge, 0 net charge. As for the ionic compound, should it be always a binary ionic compound? And the answer is no. So what happens is, as long as it can form ions, let's look at this one. Let's look at this. There are certain atoms that they always come together and form the same group all the time. For example, nitrate. It always comes with 1 nitrogen and 3 oxygen come together and form this whole group, just form a negative charge. In this case, we call this polyatomic ion. A polyatomic ion is a group that always have the same ratio of atoms and the type of atoms, and it carries the same charge all the time. So this group, this polyatomic ion, it carries a -1 charge. Let's say if I have sodium that prefers to have a positive charge, when that combines with the nitrate prefer to have a -1 charge. Now I can have an ionic compound that is made up of more than 2 elements. So we don't call this a binary ionic compound. We just call this polyatomic ion. This one, a metal, and metal should be +1 for the alkali, and this one is given, it's -1. So the overall charge or the net charge will be 0. All right, so let's put a summary here. How do we know that a binary compound, it is an ionic compound? If you only see 2 elements, and if one of them is a metal and the other one is a non-metal, and that means it is an ionic compound. Or if you can see a metal combining with 1 or more of these polyatomic ions, yes, that is also an ionic compound. So what is not an ionic compound? Okay, let's look at this. We call that molecular compound. What is a molecular compound? Let's look at this one. is a combination of non-metals. Okay, so we talked about the combination of a metal and non-metal. What happens if we have, let's say, a binary compound of a non-metal and a non-metal? Let's look at here. Let's look for this one is carbon, this one oxygen. Carbon is a non-metal and oxygen is also a non-metal. When they combine, for example, it can be carbon monoxide, CO. So in this case, this is not an ionic compound. We call this a molecular compound. Or we can form carbon dioxide. It is from a non-metal combining with a non-metal. In this case, this molecule, it is not an ionic molecule. It is a molecular compound. All right, so let's look at some properties of an ionic compound. Usually, ionic compounds will have a high melting point, and when it melts, it actually can conduct electricity. So that is a typical property of ionic compound, especially the ones that combining a metal with a non-metal. Example, sodium chloride. It has a high melting point. It is 800 degree, 801 degrees Celsius. When this ionic compound melts, it actually can conduct electricity. Sodium chloride and other salts, other ionic compounds that dissolve in water, it has a very special property. It actually conducts electricity. Anything that can conduct electricity when it is in aqueous form, we call that electrolyte. So ionic compounds, if they can be dissolved in water, it is an electrolyte. The question is, will all the ionic compounds soluble? And the answer is no. For example, if we have aluminum oxide, it is not soluble. Okay, so there are many ionic compounds that are not soluble, and therefore when you put that in water, it cannot conduct electricity. The other one will be titanium oxide. It's not soluble in water. It's made up of a metal and a non-metal.